was I supposed to know by Xania Monet.
Artist Xania Monet.
Xania Monet.
Name of
Xania Monet.
Radio
Because for so many people,
they think she's not real.
$5 million. 5 million. That's how many people have tuned in to this new hit song by Xania Monet titled How Was I Supposed to Know? Now I know what you're thinking. 5 million, that's a lot of views, but it's not all that many. Many popular artists get tens, hundreds, even billions of views on their most popular songs. But what if I told you that Xania Monet isn't a real person? That's right, Xania Monet was generated using artificial intelligence. But how have we come this far? How has AI come from being some sick party trick to generating real music that people actually listen to? How can one supercomputer generate infinitely unique songs in seconds that takes humans months, even years to make? Well, I don't know much about much, but I do know a little bit about music. So let's take a deep dive into the mathematical genius that allows AIs like Sonos to make real music. It's pretty cool. Check this out. Imagine for a second you have two infinite jars of sweets. One full of chocolate chip cookies and one full of candy corn. Now, you realize that you like chocolate chip cookies way more than candy corn, but you understand the importance of having a balanced diet. So occasionally you switch between eating chocolate chip cookies for a day and candy corn for a day. Let's add numbers to the situation. Let's say the day you eat chocolate chips, there's a 20% chance that you'll switch to eating candy corn the next day. And the day that you're eating candy corn, there's a 70% chance that you'll switch to eating chocolate chips the next day. Let's put these percentages into a chart to organize our thinking, labeling our chocolate chips and candy corn. Now, probability tells us that if there's a 70% chance that you'll switch to eating chocolate chips, there's a 30% chance that you'll stay eating candy corn. Likewise, if there's a 20% chance that you'll switch to eating candy corn, there's an 80% chance that you'll stay eating chocolate chip cookies. Now, let's remove those pesky labels because we don't need them anymore. We can just think that in our mind, and let's change those percents into decimals. What we have here is a Markov matrix. Now, I can't take credit for this genius idea. The original idea was thought up by a Russian mathematician that goes by the name of Andrey Markov, born way back in 1856, which is why we call these matrices Markov matrices. You get it? Because his last name is Markov? Now, how is this matrix actually useful? We haven't done anything with it yet. Well, if we multiply this matrix by a smaller matrix with the one in the column that we want to analyze, we now have a list of probabilities that can then be sent to a computer to simulate human decision making on these cookie jars. Now, let's throw away the idea of magical cookie jars and instead think if we made a music Markov matrix. If a computer got its hands on a music Markov matrix, it could simulate human decision making when making a melody. It's AIs like Sonos that push this idea to its limits to generate music that sounds just like a human. But how exactly do they go about doing this? Let's simulate what AI is doing here on a smaller scale to see if we can get a better idea of what's going on. Stay focused, because here comes the fun part. The first thing we're gonna need is some music, and what better artist than Michael Jackson himself? We'll quickly steal his music off of the internet, and then change those pesky note names into numbers, because computers love numbers and letters are useless. We'll do this using a mod 13 number system, assigning a different number for every letter in the musical alphabet. That's 12 different numbers and the number 0 to account for the absence of a note called a rest. After about 10 hours, I've completed this process for every note in the melody of Billie Jean. It looks a little bit like this now. Next, we'll find the probability that any given note will change to another note in order to make our Markov matrix for this set of music. In order to do this, we'll choose two notes. In this case, an easy note is 5 and 3. We'll count how many times 5 goes to 3. That's right, 10 times. Next, in order to make this number a probability, we'll divide by how many times 5 shows up in the dataset. In this case, it's 32 times. That gives us a probability of 5/12 or 0.3125. So we'll fill in that probability for the corresponding column and row in our matrix. Now, I could be here for another 10 hours filling in columns and rows of this matrix, or I can write a computer algorithm to speed up this process. Notice how we only have values in the columns corresponding to the key that we are in, F-sharp harmonic minor. This means we've effectively taught our computer how to play in a key. Now that we have our Markov matrix, we can use another computer algorithm to repeatedly multiply by this matrix in order to generate different pitches for our melody. Many of you nerds out there may know that a melody doesn't just have pitches, it also has rhythm. So we'll repeat this exact same process using a different mod 6 system for rhythm. Now it's time for the moment you've all been waiting for. Let's put the rhythm and pitches together to generate music. Let's see what we're working with here. Let's first start with our original melody so you can get a feel for what the song is supposed to sound like. Now, our computer generated one. Alright, that was pretty funky. Now let's see what happens if we train our computer on more than one Michael Jackson song. This time 3. And last but not least, let's see what happens when we switch up those chords. Overall, this is a pretty cool party trick. We've generated music just based off of a computer algorithm. But personally, this isn't the type of music I would listen to. And I think we can all agree that this is nothing compared to real Michael Jackson music. So where do we go wrong? How can artificial intelligence make music that sounds just like real human music in seconds, but my music sounds like complete and utter trash? Was all that hard work for nothing? Well, that's because we've been thinking small. We've only been considering one previous note when deciding what the next note will be, while real musicians take into account the entire song when choosing what their next note will be. We have been generating melodies completely separate of the chords that are underneath them, while real musicians generate beautiful melodies that complement the chords that are underneath them. We've been generating pitch and rhythm separately, while real musicians generate pitch and rhythm simultaneously. We've only chosen select pieces from Michael Jackson's wide genre of music, which makes it difficult for us to capture the musical genius that is Michael Jackson's essence. Bigger is better. Imagine if we combined our pitch and rhythm matrices into one giant matrix. Then imagine if we took into account not one, not two notes, but the entire song when we are choosing what our next note will be. Then imagine if we took into account all of Michael Jackson's songs, not just 2 or 3 of them. Imagine the size of that matrix. It would be huge. Imagine the biggest matrix you can. Then raise it to the 12th power. Then take to the factorial of it. Matrices that are millions and millions of digits long. That's right, a matrix bigger than your mother. Now, of course, the time and effort it would take to generate a matrix of this size just wouldn't be worth it. It took me a month to make a 13 by 13 matrix that just makes trash music. Now imagine millions and millions of lines of code and hours of manpower trying to debug those millions and millions of lines of code. The ends don't justify the means. So we'd be better off just writing music the old-fashioned way, right? Wrong! That's where AI comes in. Training computers is literally its job. An artificial intelligence system can write millions on millions of lines of code in mere hours. Millions on millions of lines of code that can be used to make a nearly perfect music Markov matrix. That's exactly what these giant AI companies are doing, like Sonos and Mubert. They're spending millions, scratch that, billions of dollars on these giant data centers, sucking up millions of natural resources just to perfect a music Markov matrix. And this isn't some new revolutionary idea. Markov matrices have been around for hundreds on hundreds of years. I found a research paper written on this exact topic published 10 years ago. The idea was always there. Artificial intelligence just pushes that idea to its absolute limit, which is why we live in the world we live in today, where musical masterpieces can be written in seconds. Xania Monet. Wait, Xania Monet. Michael Jackson. Whoa. Is this camera on? Whoa! Oh. Man, who moved the chair? Oh yeah. Oh yeah. Select pieces from Michael Jackson. I hope you enjoyed hearing me yap for the past few minutes about music and math. I find this topic very interesting, but I'm just a college student. So if you see anything that I did wrong, make sure to write about it in the comment section below, and I'll make sure to read it. And if you want to watch another cool video, you should probably click on the card you see on your screen now. That's all for now. I'll see you guys next time. Peace!